Assalamualaikum brothers and sisters. We meet again for part 2 of our Pspice simulation tutorial. Okay, so as I mentioned in part 1, we're going to construct a circuit that use a signal that changes with time. Alright. So I'm going to create a new project. So I'm going to call this half wave rectifier. So I'm just going to put HW rectifier. Again, I'm going to put this in the project folder. Okay, create a blank project. Okay. So I'm not sure whether you have covered this in your lecture, but anyway, so this is the circuit for a half wave rectifier. So you're going to give a sinusoidal input voltage to a diode, and the output is measured across a resistor. Okay, so for the input signal, because it's a voltage source, we're going to go to the library, source again, and this time we're going to choose V Sine. Okay, the reason why we do not choose VAC is because we cannot define the frequency, and it is easier if we can use V Sine. Yeah? So where is it? So it's V Sine. So there it is. Okay, so I'm going to put this here. Alright, so let me unzoom a bit. Okay, so next is the diode. Okay, the diode is a special library called eval. Eval is a library that consists of a specific types of devices. So you can see here all the codes. Okay, so for example, for a silicon diode, it's D1N4002. So D1N4002. So let's find it. D1N. So this is it. Okay, so this is the types of diode that we are going to use. Even in our experimental work, we're going to use this diode. Okay, right. And then next is resistor, which we are going to get it from the analog library. Okay, so where's my R? Right, so I'm going to make it vertical. Okay, so next is the wire. So remember to make sure you connect to the correct box. Next is my ground. Okay, and don't forget to connect ground to the rest of the circuit. Okay, so I think I'm going to leave the resistor to 1 kilo ohm. Now to define the sine wave voltage, okay, so V offset is basically how much voltage do you want the sinusoidal signal to be shifted up or down. I want it to be at the 0 axis, so I'm just going to put 0. Okay, and let's say I want the amplitude to be 5 volt. Okay, and the frequency is 1 kilohertz, so I'm going to put 1 kilo. Alright, so the default unit is hertz. So if you put 1k, it means at 1 kilohertz. And as for the AC, I'm just gonna leave it as 0. Okay. Okay, so next is the simulation profile. So HW rectifier sim. Okay, so this time you are going to create a time domain output. Alright, so we know that the frequency is 1 kilohertz, which means that for one cycle, okay, one cycle, the period will be 1 millisecond. Okay, 1 over 1000 hertz is 1 millisecond. So we want to see how many cycles. So let's say I want to see 3 cycles. So I'm going to set this value to 3 milliseconds. Okay, so we're going to start saving data after 0 seconds. And maximum step size is that we want to have the data taken after how many seconds. So normally I want to have a smooth data. So just to illustrate to you, let's say if I put 0.1 millisecond, Okay, and I'm going to apply this. Right, I'm going to click OK. And next is we want to view the output. So this is a new thing I'm going to show you. It's called a voltage marker. So this is similar to your oscilloscope, because oscilloscope is used to display your voltage signal. So I'm going to put one at the input side, which is the sine wave, and the output side. We want to see the output kan. Alright, so hopefully there's no error. I'm going to run it. Okay, so this is the output. Okay, so you can see the green one is your input signal. So if we go back to the schematic, you can see the marker here is green, represents the input signal. So it's 5 volt amplitude. Okay, and the output is the red marker. So this is the output. Okay, so later in your theoretical class, you will learn that the output will start at a later time. This is because the diode will have to wait for the input signal to reach V gamma. Then only it will turn on, and then only you can get the output signal. Okay, and during negative cycle here, the diode is turned off. Okay, so that's why there is no output voltage. V equivalent to IR. Your I is 0, so that's why the output voltage is 0. So you can see here, okay, it's not that smooth, the graph, right? So what you can do is, this is where I want to show you. You can go back to the simulation profile. You can edit and change this. So basically, we want to take the data at smaller interval. So at 0.01 millisecond. For example, you apply. Okay, then you run it again. And you will see the difference. See how smooth it is compared to when we use 0.1 millisecond just now. Okay, so I hope you can understand the concept of the voltage marker. Basically, we want to see the input signal and the output signal. Similar concept to the probe of the oscilloscope. Of course, you can just see one by one. Let's say you just want to see the output, and you run as usual, and you will just see the output. But the main purpose of oscilloscope is to view how the output changes with respect to the input. So I think it is important for you to use the marker at the input as well. Alright, okay, so that's it. So that's the end of tutorial part 2 for the half wave rectifier. So the next tutorial, I'm going to do a schematic for the op-amp inverting amplifier. Actually, for your open-ended lab, you are going to do a simulation for non-inverting amplifier, and then you will do the hands-on experiment. That's why I want to show you how to do the schematic for the inverting. Okay, so you have an idea on how to begin. Thank you. Assalamualaikum.